Hello my dear students, welcome to my channel Dey Sir's Chemistry Coaching. Okay, now for the coming days before your chemistry exam, I will upload some very important videos for your forthcoming exam. So please check it and do. So the first question. The value of rate constant for a zero order reaction is 5 into 10 to the power minus 2 mole per liter per second. The initial concentration of the reactant is 10 moles per liter. What is the value of half-life period? So remember it, you will get one question relating to half-life period, whether it is for first order reaction or for zero order reaction. So the answer is, you know that for first order reactions the half-life period that is T half. For zero order reaction, for zero order reaction the half-life period T half equals to initial concentration of reactant by 2 into rate constant. For zero order reaction the half-life period T half equals to this. So the initial concentration of the reactant is given 10 and 2 into value of rate constant is given 5 into 10 to the power minus 2. So 10 divided by 10, 5 to the 10 into comes up, so it is 100. So the answer is 100. So unit, half-life period is a time and time is given in second. So the answer is second. So whenever you write the answer, always put this type of marks, okay? Whenever you write the answer in your board exam answer sheet, always put a mark here. Now see the question. If same type of question will come from first order reaction, so what to do? So see the question, okay, I will change it. Another question, the value of rate constant for, say, for first order reaction is this. Say I will change another question, this is another question, okay, second inverse. Initial concentration is same, this. What is the value of half-life period? See the question, I have changed the question and this is second question, okay, question 2. The value of rate constant for a first order reaction is this. The initial concentration of the reactant is given. What is the value of half-life period? Actually, this sentence is given to confuse you, okay? The half-life period of first order reaction, the half-life period of first order reaction is independent on the initial concentration of reactant. Remember it, the half-life period of first order reaction is independent on initial concentration of reactant. So the formula is 0.693 by K equals to 0.693 K. K is given, C, rate constant 5 into 10 to the power minus 2 equals to, just do the answer, okay, just do the answer, it will becomes around 13.86 second, around 13.86 second, okay. So remember it, you will get one question from zero order reaction or one question from half-life from first order reaction relating to half-life period. So remember the main two formulas for half-life period. This is my direct classroom pattern, okay. So go with me. For first order reaction, this is for first order reaction. So for first order reaction, the half-life period this. So half-life period is independent on the initial concentration of reactant, while for zero order reaction the half-life period is directly proportional to initial concentration of reactant. It's for zero order reaction. So remember it, for first order reaction, the half-life period is independent on the initial concentration of reactant, while for zero order reaction, the half-life period is directly proportional to initial concentration reaction. So what is the conclusion? For first order reaction, this is very important point. For first order reaction, the half-life period that is T half is independent on the initial concentration of reactant. So remember it, for first order reaction the half-life period is independent on the initial concentration, while for zero order reaction the half-life period is directly proportional to initial concentration of reactant. So follow the next question, okay? This is the graph given between rate and concentration. What is the order of the reaction? Another question, a reaction is second order in respect to A is the reactant, and first order in respect to B is another reactant. Write the differential rate equation. So the answer, remember it, for zero order reaction the rate and concentration independent on each other. That is, for zero order reaction the rate of the reaction does not depend on the concentration of reactant. That's why the two lines become parallel to each other. That's why this is zero order. The reaction is of zero order. Second question, a reaction is second order with respect to A and first order with respect to B. Write the differential rate equation. So the answer is rate equals to minus dR by dt. I have seen questions relating to this. Instead of giving direct differential rate equation, sometimes they have given this, find this, okay, this and this are same, equals to, whenever you write any rate equation, one constant will arise. Now, according to the question, the rate depends on the second order of A and first order of B. So this is the answer. This equation is called differential rate equation. So can you tell me what is the overall order of the reaction? So listen, the overall order of the reaction is 2 plus 1, that is 3. So it is a third order reaction, okay? It is a third order reaction. So I think you understand it. Clear? Now the next question, question number 4. Listen the question. So question 4A. What are miss metals? Mention its uses. So what are miss metals? Mentions its uses, okay? Now listen, miss metals are alloy of lanthanoids. It contains a mixture of lanthanoids along with another transition metals. This type of alloy are used in lighter, flames, tracer, bullets, etc. You have seen in gas lighter, whenever you push it, you see here fire is there in gas lighter, in lighter. So mixed metals are a type of pyrophoric alloys. What are pyrophoric alloys? Pyrophoric alloys are those which on heating, on striking produces fire. So see the answer. These are alloy of lanthanoids. Composition is not asked in exam, still write it. It contains mixture of lanthanum and neodymium. %, cerium 45%, iron 4%, traces of carbon, boron, etc. Boron, aluminium, that is 1%. So these are the compositions of mixed metals. Actually, I don't think this will come. Write the composition. What are mixed metals? These are the alloys of lanthanoids. These are the types of, these are types of pyrophoric alloy. These are the types of pyrophoric alloys. What are pyrophoric alloys? They produce fire on striking. They are used in lighter, flints, that is the gas lighter, tracer, bullets, etc. This is another important questions for your time, okay? I think you understand it. So follow the next question, that is question number 4B. Follow the next question, that is question number 4B. The question is, name the lanthanoids which is radioactive in nature. Number 2, what is the common oxidation states? What is the common oxidation state among the lanthanoids? What is the common oxidation state among the lanthanoids? Okay. And the third question, that's another important questions for your time. This is another important questions for your time. Lanthanum hydroxide is more basic than lutetium hydroxide. Why? So see the answer of the questions. Okay, the first question is name the lanthanoids which is radioactive in nature. Remember it, all the lanthanoids are available in nature, that is they are naturally occurring elements, but the exceptional is promethium. Promethium is the only lanthanoid which is radioactive in nature. So the only lanthanoid which is radioactive in nature is promethium, which is radioactive in nature. Next question, what is the common oxidation state among the lanthanoids? You know that lanthanoids show +2, +3 and +4 oxidation states, but +3 oxidation state is the common oxidation state among all the lanthanoids. So it is +3 oxidation state. Now this is another question. I think this question will come for your time. Lanthanum hydroxide is more basic than this. So listen, the basicity depends, don't write, only listen it, I will write the answer. The basicity depends on the tendency to lose hydroxide ions, that is OH negative ions. Greater the bond length, more will be the tendency to release hydroxide ion. So due to lanthanoid contraction, the size decreases from lanthanum to lutetium. So the bond length of lutetium OH is shorter than lanthanum OH. Hence, lutetium hydroxide does not lose OH negative ion easily. This is the question. Hence, it is less basic than lanthanum hydroxide. Hence, it is less basic than lanthanum hydroxide. Okay, I think you understand it. Hence, it is less basic than this. Listen the question. Name the oxometal anions of first transition series in which the metal exhibits the oxidation state equals to its group number. Once again, what are oxometal anions? Some of the transition metals form oxides. They exist as anions actually, that is negatively charged ions, that are called oxometal anions. Once again, there are some transition metals which forms oxide, which are existed as only negative charge ions. They are called oxometal anions. So the question is that name oxometal anions of first transition series in which the oxidation state and the group number, that is, you know that in periodic table there are 18 groups altogether, group numbers remain same. So the answer is, you can write the answer Cr2O7-2 ion. Anion negative charge. Oxometals means transition metals along with oxygen compound. So these are ion. Calculate the oxidation state at first. 1 chromium possesses X, 2 chromium possesses 2X plus 7 into, you know that oxygen has always an oxidation state of -2 equals to the charge. What is the rule to find the oxidation state? You know that the sum of oxidation state of all the element is equal to the charge. Therefore 2x equals to -2 plus 14 equals to plus 12. Therefore x equals to plus 12 by 2 equals to 6. So this is the answer. This is the answer. Chromium, here in this oxometal anion, chromium has oxidation state of +6 and the group number, that is chromium, belongs to 6th group in periodic table. So chromium has oxidation state of +6 and the group number in periodic table also 6. I think you understand it. Similar type, similarly you can write the answer here also. Another answer, CrO4 -2. Here also chromium has oxidation state of +6 and group number also 6. So I think you understand it. Another example, okay, the second, another example, this is another example. You can write another example also, whichever you can remember it, write it, okay. The another example, example 2 is Mn2O7 minus permanganate ion. The answer is MnO4, okay. You can write MnO4 -2, MnO4 -2, MnO4 negative ions. Here the oxidation state of manganese is X plus 4 into -2 equals to, this is -1 actually, this is -1, therefore X equals to -1 plus 8 equals to plus 7. So the oxidation state of manganese is +7 and the group number of manganese also +7. So oxidation state of Mn is +7 and group number of Mn in periodic table is also 7. So this is the answer, okay. See the questions. Complete the following reactions. This is an ester containing a double bond. First step, use diisobutyl aluminium hydride. After that, hydrolysis with water. Second question, the same compound is there, only use with aluminium, lithium aluminium hydride. Third question, this is acetone reacts with DNP. What are the products formed? Very important for your time. This is the most important questions. This is important in another aspect I will discuss. Listen at first. Diisobutyl aluminium hydride and lithium aluminium hydride both are used as reducing agent in organic chemistry, but the difference is that lithium aluminium hydride is stronger reducing agent than diisobutyl aluminium hydride. As it is a very strong reducing agent, so it reduces the ester group into aldehyde as well as the double bond. So you get the product. Actually it furnishes nascent hydrogen which is responsible for reduction. So listen, being very strong oxidizing agent, lithium aluminium hydride reduces both the double bond as well as the ester. See the product as it is. CH2 double bond changes to single bond CH2 and you get here aldehyde. Diisobutyl aluminium hydride is weaker reducing agent than lithium aluminium hydride. That's why it reduces only this. It does not reduce the side chain. So the product you get CH double bond CH, here CHO. DNP has full form dinitrophenylhydrazine. Actually it is called 2,4-dinitrophenylhydrazine. Whenever it reacts with aldehydes or ketone both to form a red precipitate. That's why DNP reaction with DNP between acetaldehyde or acetone is the identification test of aldehydes and ketones. So remember it, both aldehydes and ketones react with DNP to form a orange red precipitate. In any reaction, if you get any precipitate or product has characteristic smell or there is change in color, remember it, these are the identification tests. So here how to write it, there is one technique to write. Listen the technique. Write acetone this way plus DNP 2,4-dinitrophenylhydrazine. Actually write this way, okay. Put a benzene ring. Mark it 1, 2, 3, 4. So at 2 and 4 position, insert 2 nitro group. Actually the full form of DNP is 2,4-dinitrophenylhydrazine. So the product you get, why I have written this way? To show that water is eliminated. So the product you get CH3, CH3 double bond, nitrogen as it is, NH as it is. Draw the benzene ring including the nitro group as it is. So the name of the product is 2,4-dinitrophenylhydrazone, 2,4-dinitrophenylhydrazone. I think you understand it, okay? So follow the next question. Listen the reactions. It is aniline. This is acetic anhydride. These are toluene. Now the first reaction, it's another important reaction. I have seen direct question. What happens when? All the three are very important for your time. When aniline reacts with acetic anhydride, then you get Listen the technique. Remove one hydrogen by this. So you get the product NH and write this in reverse pattern. This is called acetanilide. The reaction is called acylation. Acylation or acetylation. Sometimes it is called acetylation reaction. And the byproduct is CH3COOH. Acetic acid is the byproduct. Here toluene, this is oxidizing agent. When potassium permanganate is dissolved in dilute alkali, that is sodium or potassium hydroxide, the resulting solution is called alkaline potassium permanganate. It's a very strong oxidizing agent and it oxidizes the methyl group into carboxylic acid and side product is water here. Here it is also, this is chromyl chloride. It also acts as oxidizing agent in organic chemistry. But chromyl chloride is a weak oxidizing agent. That's why the methyl group will change into aldehyde only. So you get benzaldehyde. This reaction is called ETARD, ETARD reaction. The reaction is called ETARD, ETARD reaction. One thing remember it here, that's a very important, okay? See the topic, this is very important topic, see it. See the topic here. It is not only methyl group, any alkyl group extra, see, any alkyl group on benzene, this is ethyl benzene, when treated with alkaline potassium permanganate undergoes oxidation. So though here 2 carbon atoms, but on oxidation you get only 1 unit of acid plus carbon dioxide and water are byproduct. Another, remember it, if there are 3 carbon atoms on benzene ring, still on oxidation with alkaline potassium permanganate you get only single unit of carboxylic acid. You get only single unit of carboxylic acid. This is the interesting fact. So remember it in this way. The alkyl group of benzene on oxidation with alkaline potassium permanganate oxidizes to single unit of carboxylic acid group irrespective of the number of carbon atom in alkyl group. Whatever the number of carbon atom in alkyl group attached to benzene on oxidation with alkaline potassium permanganate, all the alkyl groups will change into single unit of carboxylic acid. This is the interesting fact of these reactions. So see the another reactions, what happens when, okay. See the questions, okay. These are also very important questions. First, acetaldehyde reacts with ethyl alcohol in presence of dry hydrogen chloride gas. Second question, acetone reacts with ethylene glycol in presence of dry HCl gas. So listen the answer. This is acetaldehyde, right answer in this way, okay. Acetaldehyde, draw the structure of acetaldehyde this way, plus ethyl alcohol. Actually this step is reversible in nature. If you forget, no matter. How to write the answer? See the answer. Whenever ethyl alcohol dissociates hydrogen positive charge O negative charge, and here as oxygen is more electronegative than carbon, so oxygen attracts one pi bond. Thus the double bond changes to single bond, oxygen becomes negative charge, hydrogen becomes positive charge. This is a type of nucleophilic addition reaction, and you know that oppositely charged ions are attracted by each other. So the hydrogen positive ion gets attached here, and the rest, this oxygen attached here. So you get the product CH3COH O C2H5H. This is called hemi, HEMI, hemi acetal. This is called hemiacetal. This compound again undergoes reaction under the same conditions. You need not add anything, okay. Under same condition you need not add anything, and finally this hydrogen is replaced by C2H5. So you get the product CH3CO C2H5 O C2H5H. This is called acetal. Acetaldehyde, when reacts with ethyl alcohol in presence of dry HCl gas, at first hemiacetal is formed, which further reacts under the reacting condition to give acetal. Replace this hydrogen by C2H5 group, you get acetal. Here acetone does not form acetals. Acetone does not form acetals, but it reacts with ethylene glycol to give, listen how to write the answer, CH3C double bonded O CH3. Draw acetone this way, okay, plus here HO CH2 CH2OH. Write ethylene glycol this way. In presence of dry HCl gas. And why do you write it? To show that water is eliminated. To show that water is eliminated. So what you see, write as it is, CH3 double bond, here just attach, no, give it like this, O CH2 CH2O. So this is the product. Acetone, when reacts with ethylene glycol, you get ethylene glycol ketals. These are cyclic ketals, okay. Ethylene glycol ketal, KETAL, ketal. Actually these are cyclic ketals. So I think you understand it. Sometimes I have seen board question, what are acetals? Okay. So the next question directly. I think you understand it. Okay. I will delete it. Follow the next question. What are acetals? Next question, question number 9. What are acetals? What are acetals? Okay. What are acetals? If you see the structure, the carbon contains two ethoxy group, OC2H5 called ethoxy. Once again, if you see the structure, the carbon contains two ethoxy group. These are alkoxy group. If any carbon contains two same groups, atom or group, they are called geminal or gem. So acetals are gem comes from geminal. Once again, if any carbon contains two same atom or groups, they are called geminal or gem. Acetals are gem dialkoxy. Acetal are gem dialkoxy compounds. Dialkoxy means ethoxy. They are called ethoxy, methoxy are called alkoxy groups. Okay, ethoxy, methoxy are called alkoxy groups. So acetals are gem dialkoxy compounds. See the reactions. This is aniline. This is acetamide. Aniline reacts with aqueous solution of bromine. It's also called bromine water. In another sense, you can say it it's a reddish color substance. Okay. When aniline is treated with bromine water solution, the reddish color of bromine water will disappear and you get a white precipitate of 2,4,6. A white precipitate of 2, 4 and 6 tribromoaniline plus side product you get it 3HBr. So put 3 here. It's called 2,4,6 tribromoaniline. It is a white precipitate. So remember it, during any reaction, if precipitation occurs, the reaction is an example of identification test. So bromine water reaction is the best identification test of aniline. So remember it, in organic chemistry, if there is any question relating to identification test of aniline with any organic compound, just write this reaction, because it is only aniline which gives a white precipitate with bromine water solution, and bromine water has darkish red color substance. The color of bromine water is decolorized. Phenol also undergoes the same reaction, but as phenol is not in your syllabus, so I am not discussing it. Okay. This is acetamide when treated with bromine and sodium hydroxide. Can you tell me what is the name of the reaction? The reaction is called Hofmann bromamide degradation, reaction. And what is the technique behind it? Just remove this group. What you see, write CH3NH2, methylamine. You should remember the byproduct. Sodium with this forms sodium carbonate plus sodium combines with bromine to form sodium bromide plus water 2 and put 4 here. This is the balanced reaction. Remember it. This reaction similarly benzamide, benzene having amide group, benzamide, this is benzamide, also undergoes the same reaction with bromine and sodium hydroxide. Just remove the CO group and you get aniline plus the same byproduct sodium carbonate plus sodium bromide, same type of balancing. So I think both of the reaction will come in your time. So tomorrow also I will upload another video. That's the final revision model questions. Please do subscribe my channel and press the bell icon. Thank you for being with me.